We have covered LLaVA models a lot on the channel. LLaVA models are large language with vision assistant, and they have been quite popular when it comes to smallish vision models to describe the images. They are not as good on OCR as the other vision models are, but still they perform the task despite of their small size. In this video, we are going to install this NanoLLaVA 1.5 model on our local system, and then we are going to try it out on few of the test benchmark images. This model is a next version of the NanoLLaVA 1 or the simple NanoLLaVA, which already we have covered on the channel. These models are called as small but mighty because they consist of 1 billion, or the new one is just 700 million parameter model, but yet they run quite efficiently to describe the images. But despite of the fact that they are vision models, you can even run them on the edge devices, and that is where I see most of their usage. As I mentioned earlier, this 1.5 version is an update from the version 1 which we already have covered on the channel. I will drop the link to its Hugging Face model card in video description, where you can also find a bit more information around its training data, some of the fine tuning, and some of the usage code. Before I show you the installation, let me give a huge shout out to Mass Compute, who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video description, and also I am going to give you a coupon code of 50% discount on range of GPUs, so do check them out. Okay, so let's get started with the model. So this is my Ubuntu system where I'm going to do installation, and I have this NVIDIA RTX A6000 GPU with 48 GB of VRAM. Now let me clear the screen, and I'm going to create a Conda environment where I will keep everything separate from my local system. Let's wait for it to get created. That is all done. Let me also create a Jupyter notebook because that is where I'm going to install it. So these four commands, first one is installing the Jupyter, second one is just resolving a bug around charset and reinstalling it, and then I am launching the Jupyter notebook. And this Jupyter notebook is going to launch this in the browser window. So let's wait for it to get launched. It takes around 20 to 30 seconds to get everything installed. Okay, there you go. So it is opening it in the browser. Let's wait for it to open. Then click on File, New, and then Notebook. That is all done. Let's install some of the prerequisites. So here we are installing transformers, accelerate, and flash attention. So let's install it. Let's wait for it to get installed. Okay, so you might see this error where it is saying that torch is not available because torch is installed in my local system but not in my Conda environment. So I'm just adding the torch here, and now let's install it. Okay, so I think I would just need to first install the torch and then use it. Okay, let's do it this way. And once this is installed, we are going to install the rest of the lot. Torch is installed, and now let's install all of this rest of the lot. Let's wait for it to finish. All the prerequisites are done. Now let's import these libraries which we have just installed, including our torch, transformers, and pillow. I don't think so we have installed pillow, so we also need to install the pillow here with pip install, and you can do pillow here. Let's run it. And that is all done. And now let's grab our model and its tokenizer from Hugging Face. And this is the model NanoLLaVA 1.5. And first we are getting the model with all on the CUDA device, and then we are going with the tokenizers. Model is done. Let's specify our text prompts now. In the text prompt, all I'm doing is I'm just asking to describe the image, and then I'm putting it in the prompt template. We are converting we are applying the chat template to the text, and then we are taking the tokenizer, chunking it, and then converting it into input IDs to be fed to the model. So let me run it. And there we have our chatml template where there is a start of the message, and then there is a user and assistant roles. And now let's specify our image. I'm just going to use this image, and I will ask the model to describe this image. It is on my local system, so let's give the path to it. So this is where I'm opening the image with pillow, and then I'm converting it into the tensor. So let me run it, and that is all done. And now let's pass it on to the model to generate the output, and then we are printing it out. So let me run it. First time it is going to take slightly more time than the rest of the runs. And there you go. So the model has come back with the response. Let me show you the image again. So this is the image where is that there is a dog, and then there is a bucket. And there you see it says that in the center of the image, a small adorable dog with a coat of brown and white is the main subject. The dog's eyes are wide open, revealing a sense of curiosity and alertness. It is comfortably nestled inside a large silver bucket, which is placed on a vibrant orange background. That is true. The bucket is slightly tilted. Let's see it again. Yeah, maybe not. Okay. Maybe due to the angle of the dog. And then adding a dynamic element to the scene, the dog's head is slightly tilted upward. That is true. If it's trying to peer inside the bucket. The overall image gives a sense of playful moment captured, with the dog seemingly ready to explore the world inside the bucket. Very, very good stuff. I think such a small model, 700 million size, and then it has described the image like any other model. Okay, so let's see how the OCR goes. So let me show you the OCR image. And for the OCR, I'm going to go with this image, which seems quite complex. It has some of the alphanumeric characters, some brackets, and then there are some non-English words, and then some umlauts and other sort of stuff. So let's run it. I already have given it the path, so let me run this thing. Let's pass it to the model. Model is going to take a bit of a time, and then it is going to print us the response. So let's see how it does OCR. There you go. So you see it is quicker the second time. Now, again, it is saying that um, the image is black and white photograph of a document. True, the document is written in German. Not really. It's a mix of German and English and French and few other languages. The quick brown fox jumps over this, and you see that if I show you the image, the quick was in the parenthesis, brown is in scare brackets, and so on and so forth. So it was not able to do the OCR properly, and that is what I wanted to show you. So as long as image manipulation is concerned, image summarization, image description, this works well. But for all the advanced features like OCR, I haven't found it working well. But still, I believe for the size, the model is quite good. That's it, guys. I hope that you enjoyed it. Let me know what you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, do me a favor and share it among your network, as it helps a lot. Thanks for watching.